Welcome. Good morning. This is Professor Sleeter. Hopefully everybody is safe and warm and got the message that we canceled our lecture today. So we're trying out something new here. I'm going to record the lecture here in the comfort of my house and post it and see how this works. So please bear with me and we'll see what we can do. We are going to continue our discussion of constant acceleration, and this first slide is just a review of our constant acceleration equations. Remember, we have one that has this form, okay, and there is no acceleration term. It still means there is constant acceleration. We just don't need to know its value. We can calculate one of these variables based on the others, knowing that it's constant acceleration. We also call this our average velocity equation. Okay, because the v1 plus v2 over 2 term is our average velocity, this term right here. Okay. Not sure where my drawing went. That's okay. We have a second equation, very common form. This one does not have the v2 term. Whoops, get a pen back here. No v2. So we don't need to know a final velocity. We can calculate one of these variables based on the others given this equation. Sometimes I'll call that the initial condition equation, because all the terms on the right hand side are initial conditions. The delta time and acceleration are the period we're looking at. Okay, and the last one is the no time equation. So we derived this and showed how to get it based on other equations. We don't need to know the delta time. We just need to know information about position, velocity, and acceleration. Okay. We also have our two definitions of average velocity and average acceleration. Many times this average acceleration is written a little differently, just solving, whoops, let's erase that. I'm still trying to get comfortable working in this mode. V2 equals V1 plus our constant acceleration times delta t. So a lot of times we'll write that equation in that way, and also many times we'll have a delta s, and remember that is actually our final minus our initial velocity. Okay, so just a little review there, and hopefully you remember that. Let's look at the next slide. This is a little bit of discussion that we've done already before. Get it positioned right. I'm not going to try and get up and walk the motion, but we'll try and describe it here. We've mentioned the fact that the sign of the acceleration, whether the acceleration is positive or minus, has to relate to the sign of the velocity to tell you whether you're speeding up or slowing down. So if you can imagine Professor White walking in the positive direction, okay, and think of accelerations. Sometimes it helps to think of them as caused by a force. So imagine a wind also in the positive direction. So there's our velocity, there's our positive direction, and there's our acceleration. So in this case, acceleration is going to cause an increase in the positive velocity, and we are speeding up. So the acceleration would cause us speeding up. Okay. Second case, positive velocity, negative acceleration. So now she's running into the wind. Okay, that's obviously going to slow her down. Okay, so that's case 1, that's case 2. Negative velocity. So now our velocity is to the left. negative acceleration. Okay. The signs are the same. We're going to speed up. And the last case, I think you see it coming, negative velocity, positive acceleration. The signs are opposite. We are going to slow down. Alright, so again our summary is the signs of velocity and acceleration are the same. We're speeding up. The signs are different. We are slowing down. Don't get tricked by the connotation that a negative acceleration always means slowing down. Okay, right here in this case right here we have a negative acceleration, but we are speeding up. Wikipedia says acceleration is commonly used for an increase in speed. So we're using acceleration a little differently. We're using it like a vector. So need to be careful with that. Sometimes a decrease in speed is called a deceleration. Okay, but just remember our demo here about the signs. So I'm going to stop the video here and try and break it into fairly small segments. Looks like I've been talking for about 6 minutes, so let's save this.